Hello, so today we will finish the chapter 5 and I will share my screen with you so we can start. We can start here. So the first thing I will talk about is index objects. So pandas index objects are responsible for holding the access, labels, and other metadata. Any array or other sequence of labels we use when constructing a series or data frame is converted to an index. And the index objects are immutable and it cannot be modified by the users. How to understand this? Yeah, we can see this data, this series, and then we want to change the index the value, the first index value, and then we cannot do it because it's immutable. So immutable makes it safer to share index objects among data structures, and some users will not often take advantages of capabilities provided by indexes, but because some operations will yield results containing indexed data, it's important to understand how they work. So and also in addition to being array-like, an index also behaves like a fixed size set. So how to understand this? For example, in our first series that I mentioned before, I will say, okay, A in OBG index. Okay, it said that it is true. And so how about for the data frame 3 that we created before? So data frame, where is data frame 3? Okay, it's here. So for data frame 3, what will happen? Okay, let's check. So frame 3, this is frame 3, right? And we want to say that, okay, A in frame 3 dot index. Okay, it's still true, which is great. And unlike Python says, a pandas index can contain duplicate labels. So here is how we have duplicate label. Here is how we have duplicate labels. And if we have duplicate labels, then we can select all occurrence of that label, which is good, right? So for example, for our data frame 3, we have 3 of them, and I want to change the index. Dot index is equal to dupe labels. So for frame 3, what we will have is, okay, they are the same, right? So what we can do is we can select all occurrence of that label. So frame 3, okay, that's how we get it. See, we can get 2 columns or 2 rows. And the next thing we want to talk about is re-indexing. So an important method on pandas objects is re-index, which means to create a new object with the data conformed to a new index. So how to do it? We have this object 3 and we have all these index. And what we will do next is we can rearrange the data according to the new index, introducing missing values if any index values were not already presented. So for example, what we can do is, okay, I want to do reindex and object 3 reindex. And then so I want to change the order 1, 0. Okay. So object 3, and you can see, okay, the order of the index is changed. which is not hard, right? And then what we can do is that, oh, okay, we can also add some new index here, and the value will be null. If we want to fill in something in this null value, we have some methods that we can take, for example, to forward fields, which is easy. And the next thing we will talk about is reindex can alter either the index columns or both. When passed only a sequence, it reindexes the rows in the result. So it means that, okay, when we add some new index, then the whole row will be null, right? And so that's how we do it. And we also can like assign the columns to this reindex method. And the next thing is that as we can reindex more efficiently by label indexing with the log, and many users prefer to use log. Yeah, because use log, you can assign the index and also the columns. Okay, so there are many things, reindex function arguments. Okay, so actually in this part, I'm talking a lot of things about this reindexing function, and then so there are many things that we can look at in this function. I mean, there are many arguments that we can change. So the next thing I will look at is dropping entries, which is easy. I think I don't want to talk so many things about this part because index values can be deleted from either axis. The row, or I mean, it can delete the rows and also can delete the columns. So, which is not hard. Just to remember how to use drop, how to use this function, and then everything is done. And for the index selection and filtering, what I should say is that, so this serious indexing actually works to NumPy array indexing. And so what we can do is we can use this bracket, right, to get what, so let's check. Oh, okay, this is object 3. And the 0 means the first value, and the 2 to, if we assign 2 to 4 to 9, then you can see what happened. Yeah, so this is how we get the rows. But if we want to get, for example, we want to get a columns, what should we do? So what we can do is here, okay, I want some columns. For data frame, if you just use like this, then you can get nothing. But okay, you can get nothing also in here. But if, okay, I want some columns, then this is what I can do. I use this double bracket to do this. And what I can do also is to, for example, okay, I want several 3. Okay, so how about this? Okay, how about, oh, okay, so we can see that this can only work for index Utah. Okay, that's how we get a few rows, right? And then the next thing we will look at about this filtering is that, okay, how we get different rows, and or also in data frame how we get last like a few rows. Yeah, we get Ohio and Colorado. Actually, we get the first 2 rows, right? And you can see here, we can also set some of the conditions and then get what we want. And also we can also do something which is to get the, to assign some values to some rows that we want to change. And another thing is that we can use location or iloc. So for loc, the difference is that the same thing is that they enable you to select a subset of the rows and columns from data frame with NumPy-like notation. And the difference is that for iloc, you can only choose the subset. The subset use iloc with the integer. So that's the difference between them. And yeah, so that part I will not talk too many things about this. Let's go to the next part, which is integer indexes. So in integer indexes, so let's check. Integer indexes is working with pandas objects indexed by integer is something that often trips up new users due to some differences with indexing semantics on built-in Python data structures like lists and tuples. For example, you might not expect the following things will get an error. So for example, we have this, and then what we want is, okay, what's in this series, right? Okay, we get the last value. So in this case, pandas could fall back on integer indexing, but it's difficult to do this in general without introducing subtle bugs. So we have an index content 0, 1, 2, 3, but inferring what the user wants will be difficult. For example, we have SER, and then what we want. So right now, yeah, we have, okay, we have ABC, which works very well, right? But if we change something here, okay, I have SER2, and I don't have indexing. I don't set indexing. That's the truth. That's the truth. And then what happened? And I want to get, okay, there are some problems. See? So if we have an access indexing containing integers, data selection will always be label oriented. So right now we need to use loc or alloc to find the things that we want, right? And also slicing with integers is always integer oriented. So yeah, that's how we do with the integer index, right? And the next thing we will look at is arithmetic data alignment. Actually, it's not hard because we add two, it's for us to add two data frames together and to see what happened. So for example, we have two data frames, right? They are not serious, actually. They are not the same, right? They have different index and different actually they have different index, and then I add them together. This is what happened. Okay, only that when we have the same index thing can be adding together, can be added together, and other things will be null. And if we want to do something, okay, you say, okay, I just want to add them together. I don't care if there are any, like they have the same index, and just show me the value. If they, I mean, if they have the same index, then add them together. If they don't have any same index, then just put the one with the values in my result. So that's how we do it. See, that's the how I want to get the result that I want. And the next thing we will look at is, okay, I want to do, so I want to do, so minus, what will do, what will be the results in minus? Okay, it's still the same that, okay, I use the first one to minus the second one, and if we don't have the same index, then the result will be null. So the next thing we will look at is, okay, I want a counterpart of my result. So that's how I get that result. And so when re-indexing a series or data frame, we can also specify a different field value, not just to fill in some like, null value. We can fill in many values. We also have like subtraction, division, and the floor division, multiplication, and exponentiation, exponentiation. And so the next thing we will look at is the operations between data frame and the series. So we will have, okay, as with the NumPy arrays of different dimensions, arithmetic between data frame and series is also defined. And so we can have an array, and then we have an array, and we get something. Actually, is that you can use big array to subtract a small array, right? So if you subtract a small array from the big array, then the subtraction is performed once for each row. This is referred to as broadcasting and is explained in more details as it relates to general NumPy arrays. And operations between a data frame and a series are similar. For example, when you have a frame and when you have a series, and you do some subtract, and then what it do is to, okay, arithmetic between data frame and series match the index of the series on data frame columns. So it will do something to the index or the columns when they have the same thing. And so that's how they do it. And the next thing we will look at is, so if an index value is not found in either the data frames column or the series, the indexed objects will be re-indexed to form the union. So for example, I will add the data frame with a series, and then maybe there will appear some new columns, and then the result will be null. So And also, if they cannot find the same index, then the result will be null too. So that's how we do the, how we add them together, add a frame and a series together. And the next thing we can check is if we want to, instead of broadcasting over the columns, matching on the rows, we have to use one of the arithmetic methods. For example, we can use like sub. So I will take this as an example here. Okay, this part's title is operations between data frame and the series. Actually, I've never used this kind of thing before, but I think it's very interesting because so we have frame 3 here, and then what we will have is, okay, I have a series, and my series is is only like one, maybe one value. So that value will be frame 3, which is file log file. Was serious. So for file and okay, let me check how to use log. I have forgotten. So use file, use log. Okay. And what I want is so this is a series, and I want to add them together. Series. What happened? Wow. So you can see that we have something more came out, right? So for the number 1, then we have more of the rows in these columns, in column 1, and we have more of them, and also the contents in here is changed, which is interesting. Also, let's check what it will do for it. Use this function sub. So sub series access is equal to index frame 3 sub series. Okay, it cannot work because unsupported operand for string and string. So it cannot add a string together, use this thing. So that is a problem. I think if all the things in here is integer, then that can totally work, right? Okay, so next part we are looking at function application and mapping. So okay, let me check if my time is up here. Okay, oh, it's here. Oh, so let me start another 25 minutes. Yeah, let's start. I really want to finish this part. So function, this part is called function application and mapping. Function application and mapping, that's what we want. Then we have frame is equal to pd.data frame and p.random.rc RNDN, and for 3 columns is equal to list PDE, comma, index is equal to Utah, Ohio, Ohio, Texas, and Oregon. That's all of it. Okay, so that's what we can see in these 3 columns. And then next we want to do is another frequent operation is applying a function on one-dimensional arrays to each column or row. So what we will do is, okay, f is equal to, so that's how we use them. The dot x dot x dot minimum, and we apply. So what happened here, I don't know. Okay, so I apply this to f and we can see what happened. So for this data frame, right, we get so what have we done here? It computes the difference between the maximum and the minimum of a series and is invoked once on each column in frame. So the result is a series having the columns of frame as its index. So if we pass the axis equals to columns, a function will be invoked once per row instead. So for example, f dot access equal to columns. That's the result. So many of the most common array statistics are data frame methods, so using apply is not necessary. So the function passed to apply need not return a scalar value. It can also return a series made with multiple values. So for example, what we can do is, okay, df, f, x, right? And then return what? Return pd dot series and x dot minimum x dot maximum, comma, index is equal to minimum max. So what we will do is frame dot apply f. So you can see this is the result actually for each column. Not for each column, sorry, for each, yeah, for each columns. And then we get the maximum one, and also what we get is the minimum one. So what we can do is, what we can do more is like this. Okay, x minimum minus x, right? So this is defer, and okay, so this is the result we have, and also this is what we apply the original f here, what we can get. We run it. See, so for BDE, x maximum minus x minimum, and so this is the result, BDE, and then we change to columns. What happened here? And then this is how we use the minimum and maximum, this function, to help us to get what we want. So the result is different. Let's see what happened. See, right now they are same. I think the difference comes from, for this random generated data frame or numbers, every time they will be the same, right? Okay, so let's go to the next thing, which is still the lambda. We can element-wise Python functions can be used too. So imagine we wanted to compute a formatted string from each floating point value in frame. What we can do is we'd apply map. So we have a format variable lambda x. So what we want is to change the format and dot to f x. So this is our computation, and then frame dot apply map. Apply map format. See, right now we change every this floating into 2-digit floating values. Also we can do is, okay, I want integer. So this is how I do it. And okay. Actually, anything you want. You can change the format that you want. The next thing I will talk about is sorting and ranking. So I want to talk about it. I actually have met that before, so I will see what I can remember. For example, sort. What I can remember is sort values by is equal to b. So see, okay. And yeah, let's see what they are doing here. They can sort index. They can, okay, sort values just like I do, and also do rank. So I think for rank, okay, rank is mainly used for series, but it can also use for data frame, which is, so we have 3 ways: sort index, and we can sort values, sort index, and then access is equal to 1. So BDE, okay, in the beginning they are in the right order. So actually, if for example, if here is EBD, the original order of the columns, then it will change to BDE. So that's the things. And the next start is also we can it can be sorted in descending order. Yeah, so I don't think that part is so important. And I will talk about, okay, the first thing is any missing values are sorted to the end of a series. Also, when sorting a data frame, you can use the data in one or more columns as the sort keys. And another thing is ranking assigns ranks from 1 through the number of valid data points. In an array, the rank methods for series and the data frame are a place to look. So by default, rank breaks tie by assigning each group the min rank. Yeah, so the min rank, and you can also use like method to change the rank. So yeah, here are all the things about how to do the rank, how to sort, and then let's look at access indexes with duplicate labels. So when we have duplicate labels, we can use is unique to check if all the index is unique, and we can also get all they want from the index. So what we can do else is, okay, you can also use location to find the label that you want. So if there are duplicate labels, there are different ways for you to identify the rows with duplicate labels, duplicate index. But so for data analysis, I actually, yeah, I've seen that to change like the date time into index, and there must be duplicate index, right? But I don't think that's a problem that can affect your result of data analysis. So let's go to the next last part, which is summarizing and computing descriptive statistics. So which is actually to get like the sum of the data frame and like mean of the data frame, index max, com sum, and this grab and get the correlation, and okay, do the unique values, value counts, and membership. So I think that this video is too long, so I will leave the last part of chapter 5 as in when I introduce the chapter 6. So that's all about chapter 5 in this video, and thank you for watching.